Now we're going to continue the previous example by adding some information and ask about a new situation. So in this example, a particle with a mass of 1 microgram and the charge of a -2 microcoulomb is released from the rest at point B and at point B, and the question asks to assume these two charges Q1 and Q2 are held fixed in the place, and these particles, these masses, move in the vacuum, and we're gonna ignore the effect of a gravitational. And then the question asks us what is the kinetic energy of these masses and the speed of that when these objects reach to the point B. So because we have a voltage difference between these 2 points, and we calculated the voltage difference in the previous example between these 2 points, point A and point B. So these charged particles, when it released from the rest, because this charged particle is negative, it has a tendency to move toward the positive charged particles and converted all and transfer all potential energy to the kinetic energy. And this potential energy is because of there is a voltage difference between these 2 points. What we are going to do here, we're going to check the conservation of mechanical energy, because the question said that the object is moved in vacuum, there is no friction, and we're going to ignore the gravity in this motion. So the only potential that we're going to use in conservation of mechanical energy is the electric potential. Electric potential of these single charge that generated in this situation. So let us start with the, here we have the here we have the total electric field, which is in this direction that we calculated before, and the charged particles is negative, has a tendency to move in the opposite direction of the electric field from point B to point A. So the electric field here is not constant, is not uniform, so is not constant. The force is not constant, and the acceleration also is not constant. Because of that, we cannot use the kinematic equations of the motion with the constant acceleration. What we're gonna do, we're gonna calculate the kinetic energy and the speed of this object by considering the conservation of mechanical energy. So the mechanical energy at point A is equal to the mechanical energy at point B. So because the motion starts from point B, so I'm gonna put the point B in this. So the mechanical energy is summation of the kinetic energy, potential energy, which is in the form of electric potential energy for this example. So the question said that the object is released from the rest at point B. It means that the speed of that is 0, the kinetic energy of that is 0. So we can calculate with potential energy of this charged particle at this point from the multiplication of these charged particles, charge 3, at the voltage of this point, which is VB, kinetic energy at the final point, equal charge 3 multiplied with the potential at point A. So we can set that the kinetic energy at the final point equal the charge Q2 potential at point B minus this term. So charge Q3, the voltage difference of these 2 points. So we can write it. So we have the potential at point B and A from the previous steps. The kinetic energy of these charged particles is going to be minus 2, which is the charge Q3 with the amount of minus 2 microcoulomb. Let's convert it to the coulomb. Potential at point B, that was 0, and the potential at point A that we calculated 10 power of 3 volt. So at the end we have a positive negative multiply with this negative sign, which is 1.2 10 power of minus 2 joule. So now we want to calculate the speed of that. Let's open the kinetic energy. So from the kinetic energy at point A is going to be 1/2 mass of this object, speed of that in power of 2. So the speed is going to be the square root of 2 multiplied with the kinetic energy at this point over the mass of a charge 3. So 2 multiply 1.2 10 power of minus 2 joule. The kinetic energy is in the unit of joule, so we are not worried about transferring and changing the unit of that. And the mass of a discharged particle, which is 1 multiplied with 10 power of minus 9 kilogram. So if you take a look, the mass of that is 1 microgram. Micro is 10 power of minus 6, and gram must be converted to kilogram, which is 10 power of minus 3. Minus 3 minus 6, in total 10 power of minus 9. So now we can calculate the speed of this charged particle, which is 4.9 10 power of 3 meter per second.